Out in space, in orbit around planet Earth, lies a space station where the best and the brightest come to learn. Here at Space Academy GX-1. Welcome! We've been expecting you. All crew members, please sign in. Greetings, Commander. Click a module to continue your work.
Glad to have you back. There's always more data to analyze here.
Please choose 2 safety devices that will help you complete a mission to Titania. The mission The Olympic high jump team needs information regarding gravity on the planets. Please choose which of your crew members has analyzed the data correctly. How high you could jump on a planet depends on the strength of the planet's gravitational pull.
You could jump highest in Earth's gravity.
You could jump highest in Saturn.
That doesn't seem to fit.
You know, you have excellent problem-solving abilities.
The Galactic Olympic team has requested data about planetary gravity. Which of your crew members has interpreted the data correctly?
You could jump as high. Nice one. I'm glad you're on the team.
The Solar Exercise Club has requested information about gravity. Can you select which of your crew members has the correct theory?
On Jupiter, you would weigh nothing.
You might want to re-examine the data. Try again, please.
On Jupiter, you would be heavier than you would be on Earth. Your problem solving is simply stellar.
Please choose 3 safety devices so your rocket can safely complete its journey to Europa. The mission The mission has been aborted. The mission has been aborted. The mission. The mission has been. Starship Triton has just requested information on planetary comparisons. Please choose which display shows the information you need. Then decide which crew member is correct. How high? The simulation has broken again. Earth.
How did you get to be so good at this?
Earth's orbit is in the shape of a slightly squished circle, or ellipse. Almost, but not quite, a perfect circle.
This simulation is a mess. The moon's elliptical orbit is too long. Please change the settings so that the orbit is correct.
Excellent! Glad to have you on board.
The moon's path is in the shape of a round oval or ellipse.
Now, let's have some fun with the simulator.
Please change Earth's settings so that the sun will rise in the west every 24 hours.
Get out! How do you do that so well?
Change Earth's settings so that the sun rises in the east once every 6 hours.
Nice brain work! You solve this stuff like a pro!
Change Earth's settings so that the same half of Earth is always facing the sun.
You should be very proud of that work.
Change Earth's settings so that Earth will have no seasons.
Out of sight!
Change Earth's settings so that June 21st is the first day of winter in North America. Please
To slow down the ship, fire your... To slow down the ship, fire your rockets in the opposite direction. This is called retro-firing and is the only way in space to put on the brakes. Sometimes you may need to turn your rocket around first.
Your ship is starting out already in orbit.
Control, check the right side stabilizer. Affirmative.
Mission Control, this is Robbie on X-Ray Charlie 222.
Try another angle and another. Try another thrust.
Get out! How do you do that so well?
Catherine, come back.
Your ship is starting out already in orbit.
Elephant Charlie on the Vector Class Sigma, come back.
I like the way you think.
Your ship is starting out already in orbit. Set the angle and thrust to put your spaceship into a lower orbit that's an ellipse. Your ship is now in orbit. Your ship is starting out already in orbit.
Control, check the right side stabilizer. Elephant Charlie on the Vector Class Sigma, come back.
You've got a great head on your shoulders.
To go from a high orbit to a low orbit, the spaceship needs to slow down into a smaller ellipse. Then, at the right moment, slow down again to return to a circular orbit.
Your ship is starting out already in orbit.
Atmospheric vector break to go 222.
Your ship is starting out already in orbit.
Atmospheric vector break to go 222.
Try another thrust. Your ship is now in orbit. First, set the thrust of your spaceship so it will reach the imaginary target in space. Try another thrust. Here's a thrust. Adjust the angle and thrust to put your spaceship into orbit around Earth, then hit the imaginary target.
To go from a high orbit to a low orbit, the spaceship needs to slow down into a smaller ellipse. Then, at the right moment, slow down again to return to a circular orbit.
Your ship is starting out already in orbit.
That's it go, Jay.
Welcome. Hello, Captain.
Here's the station reference guide. It's great fun.
Earth spins like a top when it rotates on its tilted axis.
Out.
Welcome. Hello,
Here's the station reference guide. It's great fun to browse through.
Earth spins like a top when it rotates on its tilted axis. It takes about 24 hours or 1 day for Earth to make one complete rotation.
Earth orbits around the Sun on a path that is almost a circle. It takes Earth 1 year, that's 12 months or about 365 days, to travel all the way around the Sun.
With enough thrust, your rocket can escape the Earth's gravitational pull.
When the Moon is 1/4 of the way around Earth, people on Earth see only half the Moon lit by the Sun. This is sometimes called the first quarter phase.
Traveling from Earth to Venus is a lot like traveling from a high Earth orbit to a low Earth orbit. But now you're moving from a higher orbit around the Sun to a lower orbit around the Sun. This trip may take a good number of stages. Do you think you're up to it? To go from a high orbit to a low orbit, the spaceship needs to slow down into a smaller ellipse. Then, at the right moment, slow down again to return to a circular orbit.
To go from a low orbit to a high orbit, the spaceship needs to speed up into a larger ellipse. Then, at the right moment, speed up again to return to a circular orbit. Ready to return to Earth? You can do it in 3 stages. First, fire the thrusters and head toward Earth. Then, get into orbit around Earth. Lastly, splash down.
To dock with the space station that's in a higher orbit than your ship, you will need to speed up at the right moment, changing your path, to intersect the station's orbit, right when the station gets there.
The full moon occurs when the Earth is between the Sun and the Moon. From Earth, we see almost all of the sunlit part of the Moon.
A hemisphere is 1/2 of the Earth. The half that's closest to the North Pole is the Northern Hemisphere. The half that is closest to the South Pole is the Southern Hemisphere.
It takes one final stage to land on the Moon. You need to slow your ship down, so that your ship will fall towards the surface of the Moon.
It often takes 2 stages, or burns, to launch this spaceship into orbit. First, you must travel up to where you want your orbit. But then, you must change your course to put your ship into a perpetual fall around the Earth. In other words, an orbit.
Time to leave the Moon's surface. First, fire your rockets on a path that puts you above the Moon. Then, change your angle and thrust to put your ship in perpetual fall around the Moon, a Moon orbit. Time to leave the moon's surface. First, fire your rockets on a path that puts you above the moon. Then, change your angle and thrust to put your ship in perpetual fall around the moon, a moon orbit.
A lunar eclipse happens when Earth passes directly between the Sun and the Moon. From Earth, we see the Moon go dark briefly as Earth's shadow passes over it. If we were on the Moon during that time, we would see the Sun darken as Earth passed in front of it. The Moon's gravity pulls an object toward it, changing the path of the object and speeding it up.
It takes the moon about 27 days to spin one time on its axis. Coincidentally, that's the same amount of time it takes the moon to orbit once around Earth. So the same side of the moon is always facing Earth.
A new moon occurs when the moon is between the Earth and the Sun. The new moon appears close to the Sun in the daytime sky. With its dark side facing us, it is often difficult or impossible to see with just your eyes.
A spaceship or other object in a lower orbit will always travel faster than one in a higher orbit.
With enough thrust, your spaceship can travel far enough away to take advantage of Earth's curved surface. Gravity still pulls at the ship, but at the same time Earth's surface curves away, so the ship never hits the ground.
It takes 2 stages to get into orbit around the Moon from an orbit around Earth. First, set the thrust to get the ship out of the orbit it is in and headed toward the Moon. Then slow down to ease into orbit around the Moon. The path your rocket took is only part of an ellipse, or oval path, that goes all the way around the center of Earth.
Half of the moon is always lit by the sun. As the moon orbits Earth, we often see only a portion of the lit half. It takes the moon about 29 days, almost a month, to go through a full cycle of these different phases.
In June, the North Pole is tilted toward the sun. As Earth spins on its axis each day, the region above the Arctic Circle stays fully lit by the sun. People who live near this region do not see the sun set for days or months at a time. This long period of sunlight is often called a polar day.
In December and January, the North Pole is tilted away from the sun. As Earth spins on its axis each day, the region above the Arctic Circle remains in the dark. People living in this region do not see the sun for months at a time. This is called a polar night. When the North Pole area has polar nights, the region below the Antarctic Circle has polar days.
If you launch your rocket at the same angle but with different thrusts, it will fall at different places.
If you launch your rocket at the same thrust but at these 6 angles, it falls at only 4 different places. Sometimes, a target can be hit using more than one angle.
To slow down the ship, fire your rockets in the opposite direction. This is called retrofiring and is the only way in space to put on the brakes. Sometimes you may need to turn your rocket around first.
A solar eclipse occurs when the moon passes directly between the sun and the earth. If you could view the earth from space during an eclipse, you would see the shadow of the moon passing across the earth's surface. A solar eclipse occurs when the moon passes directly between the sun and the earth. If you could view the earth from space during an eclipse, you would see the shadow of the moon passing across the earth's surface.
For 3 months, starting in March, it is spring in the northern hemisphere and fall in the southern hemisphere. For 3 months starting in September, it is fall in the northern hemisphere and spring in the southern hemisphere.
The Earth is tilted on its axis at an angle. Summer on Earth happens when one of the hemispheres of Earth is tilted towards the sun's direct rays. Winter comes when that hemisphere is tilted away from the sun.
The Tropic of Cancer and the Tropic of Capricorn are imaginary lines on the Earth. On June 21st, the first day of summer in the northern hemisphere, the sun's rays directly hit the Tropic of Cancer. On December 21st, the first day of summer in the southern hemisphere, the sun's rays directly strike the Tropic of Capricorn.
When the moon is 3/4 of the way around the Earth, people on Earth again see only half of the moon lit by the sun. This is sometimes called the third quarter phase.
Maddie, catch. Maddie, look how stretchy it is.
Ooh, it looks pinkish.
No, stretch it. Look how
I'm
stretchy.
gonna mix this one together and see what happens.
Look how stretchy. Mix up
This one. Put this in there.
My bad.
No, scratch it this way.
Whoa.
Hello.
This one's cool looking.
Do, do, do. Get set. Ready. Get set.
Maddie.
You mixing it together?
Yeah.
Ready?
Wow, that's a
Two.
big.
1.
You get this half. I get this half.
Okay, bad.
And both of us get a top. I get the french fry. And you get this one.
What?
No. Hi guys, welcome back. Today we're making some mini stuff. Guys, look what I have. I think I know what it is.
We're gonna be making this today?
Yeah.
Okay. And we have all the ingredients ready?
Yes.
What are the ingredients?
Show the instructions too.
Where are the ingredients?
That's the instructions.
Okay. Where are the ingredients?
It's in my fridge.
Where are the ingredients? What ingredients do you have? Can you tell us all we have that we
got
need?
the chocolate icing.
Yeah. What else?
Oh, cool. Chocolate icing. We have a stand.
Yeah.
That's
A stand for the cake when you're done.
And then we have the cake.
The cake itself.
Roll cake. Welcome back, guys. Guess where I am today? I'm at Canada's Wonderland. I heard they have a Sanrio Crow machine. And you can play games to win Sanrio stuff. Let's go try it out. See you there. Woo!
Glad to have you back. There's always more data to analyze here.
The Olympic high jump team needs information regarding gravity on the planets. Please choose which of your crew members has analyzed the data correctly. How high you could jump on a planet depends on the strength of the planet's gravitational pull. I believe that
That was truly marvelous thinking.
the Galactic Olympic team has requested data about planetary gravity. Can you select which of your crew members has the correct theory?
You could jump as high on Mars as you could jump on Mercury.
The Solar Exercise Club has requested information about gravity. Which of your crew members has interpreted the data correctly?
On Jupiter, you would be heavier than you would be on Earth.
On Earth, you would be heavier than you would be on Jupiter.
That doesn't seem to fit the data. Please try again. This information may help lead you to the right conclusion.
From now on, I'm taking pointers from you.
Please choose 3 safety devices so your rocket can safely complete its journey to Europa. The mission has been aborted for safety reasons. Please change one of your safety devices. The mission The mission has been aborted for safety reasons. One of your safety devices is not needed. Please replace it with one essential to your mission. This information will help lead you to the right answer. Starship Triton has just
Welcome back. The Earth-Sun-Moon Simulator is ready and waiting.
Now, let's have some fun with the simulator.
Please change Earth's settings so that the sun will rise in the west every 24 hours.
What an exceptional thinker you are!
Change Earth's settings so that the sun rises in the east once every 6 hours.
Way to go! It's great to have you here at the station with us.
Change Earth's settings so that the same half of Earth is always facing the sun.
Excellent! Glad to have you on board.
Change Earth's settings so that Earth will have no seasons.
Nice job! I couldn't have done it better myself.
Change Earth's settings so that June 21st is the first day of winter in North America.
That was truly marvelous thinking.
Change Earth's settings so that the South Pole will directly face the sun in December.
Your problem solving is simply stellar.
Please change the settings so that the Earth's elliptical orbit is as stretched as possible. Baffled?
Fine work! You're ready to launch a great space career.
Now let's have some fun with the moon.
Please change the moon so that the side we never see becomes visible. You're not there yet. Keep going.
Perfectly logical. Well done.
Now, let's have some fun with the simulator.
Please change Earth's settings so that the sun will rise in the west every 24 hours. Change Earth.
To go from a high orbit to a low orbit, the spaceship needs to slow down into a smaller ellipse. To go from
Elephant Charlie on the Vector Class Sigma, come back.
Try another. Try another. Your ship is starting out already in orbit.
Sigma, come back.
Roger, Control.
Your ship is now in orbit. First set the thrust of... Try another... Try... Here's a thrust. Adjust...